All right, guys, welcome back. I'm still here. Hopefully it's a new day for you. Okay, so we have 11-2 today, radical expressions. Hopefully yesterday was really easy, gave you confidence about going into this chapter. Okay, so we're going to continue on. Here are some examples of radical expressions. Okay, remember we know that the thing underneath the radical is the radicand. Radicand could be a number, could be a letter, variable, could be an expression, algebraic expression. So you'll see in your book on page 487, there's some samples. And of course, guys, during this time, I'm really going to encourage you to read your book, to study the examples, go over it on your own, kind of teach yourself, well, you're going to learn it well that way. Okay, so as I said, these are some examples of radical expressions, okay? Now, the first exercise that you're going to be expected to do is to see if the radicand or the result is a real number. Now, what have we said in the past? We are not allowed in the real number system to have a negative under the radical, okay? There is no answer to this in the real number system. When you get to Algebra 2, you're going to learn about imaginaries, and this is actually I, okay? But in our system, and for right now, you're going to say, no, that's not real, okay? So we don't have a solution for this answer. And because of that, we want to find out what we cannot have underneath the radical. So example 1 says, evaluate the expression 1 minus y for y equals 6, and then you're supposed to see if the result is a real number, okay? So you're going to plug in 6 into this, all right? So we have 1 minus 6, and so that would be the radical of negative 5. And can we have a negative radicand? No. So no. This is not real, okay? And you can just say no. The answer is either yes or no, all right? So looking at example 2, it says, determine the values of x that make each expression a real number. Okay, so again, we have a radical x. So this number could be 0, right? The square root of 0 is 0. It could be 4. The square root of 4 is 2. If it were 3, that's okay. We would leave it because we don't have a number that comes out, right? It's irrational, but it's still real, all right? But the things we're not allowed to have is a negative under there. So whatever the radicand is, if they give it to you in a variable, you'd say that radicand has to be greater than or equal to 0, okay? It can be 0. It can be 1, it can be a half, it can be a third, it can be 5 and a seventh, right? But it can't be negative. So, for example 2, I'd say radical x, and the solutions that make that real are when x is greater than or equal to 0. Okay, let's look at example 3. It says that we've got the radicand under here is x plus 2. And I want to know what solutions make this real. So again, whatever's under here, I'll put that, and I'll set that greater than or equal to 0. And now I'll solve it algebraically. I'm subtracting 2 from both sides, so 1 little old x is negative 2. It's greater than or equal to negative 2. Okay? Think about it. If I have negative 2 plus 2, 0, square root of 0 is 0, kosher. If I have negative 1, that's greater than negative 2. Negative 1 plus 2 is 1. Square root of 1 is 1. Fine. If I have 0, 0 plus 2, I get square root of 2. That's irrational, but it's a real number. But if I plugged in negative 3 plus 2, negative 1, no, can't have it. All right? So this is how we solve these problems. Okay, so the next one, determine the values of x that make this a real. Well, now this is really simple because we know that any number getting squared is going to be a positive, right? Negative 5 times negative 5 is positive 25. And I can have a positive under here, right? So for this one, I would just say all reals, right? because anything getting squared is going to be positive, and any positive number can be under the radical. All right? So take a moment, do practice A through E, turn off the video, and then come back when you're done and we'll check these. So for A, we have 15 minus 2x, and we're evaluating for x is 8. And we're supposed to see if this is a real number. All right, so 15 minus 2 times 8. Okay, so that would be 15 minus 16. Well, that's the square root of negative 1. I can't have that, so no, it is not real. All right, for try this B, I'm determining what values make this real. So I say x plus 1, I set that equal to 0. I'm going to take away 1 from both sides, and I get x greater than or equal to negative 1. Okay, for try this C, I would have x minus 3 under the radical, so x minus 3 is greater than or equal to 0. X is greater than or equal to 3. Okay, that was try this C. All right, now try this D. The radicand is 2x minus 5. That binomial has to be greater than or equal to 0. I'm going to add 5 to both sides. 2x greater than or equal to 5. X is greater than or equal to 5 halves. You may leave it improper as long as it's reduced, okay? And then lastly, E, we have x squared plus 3. Okay, and what did we say about x getting squared? Any real number or any number squared is going to be positive, and then we're going to add 3, so we know it'll be positive. So we would just say all reals in this case. Okay, so now we're ready to do part 2. Now this example, we start off and it says that remember that radical A, or square root of A, means the principal square root, the positive, or the 0 of A, okay? So the symbol x squared means to square x and find the principal square root, all right? So it shows you, is this equal to x? Well, not necessarily, because I could have had a negative x under here, and it gets squared, and it would give me x, right? So it could have originally been a negative x. So what they're assuming is that you want to always have absolute value. You always want the positive answer. I'm going to, in the situation we're under right now, I'm going to assume, you all assume, that everything needs to be the positive, the principal square root. So you'll see your answers with absolute value. You can just leave it AB. We're going to all remember it's positive, okay? So for an example, if you have this, 3x getting squared, okay, that's going to be 9x squared. The square root of 9 is 3. The square root of x squared is x. And you'll see the book shows you the absolute value. I'm going to let you forego that, assuming you remember. It could have originally been a negative x under there, but this is what we're pulling out. Okay, example 6, square root of a squared b squared. Right, this is example 6, or try this 6, sorry. So a comes out, b comes out. All right, and we have example 7, or try this 7. Now here, you guys, we have a trinomial. Now it is a trinomial square. See, I told you you would factor in for the rest of your lives. This trinomial square factors into x plus 1, x plus 1. And remember, another way to write that is like this. So if something is squared under the radical, what comes out? The x plus 1, right? That binomial itself. You can have parentheses or you don't need them. It's up to you. Okay? All right, so now try this F through K, and then we're done with this lesson. So try this F through K. Please stop the video and then do your work and then check back with me. All right, so for F, we have the square root of xy getting squared. So obviously the xy comes out. For G, it's written, they've distributed. So it's the same thing as this problem, but they've distributed this square, okay? So this answer is also xy. For H, we have the square root of a binomial getting squared, therefore the binomial pulls out, right? You can put parentheses or leave them, it's up to you. Now I, here we go, we have a trinomial again. X squared plus 8x plus 16. Okay, so this factors into x plus 4 squared, right? I could write x plus 4, or simplify it like this. And so the answer, x plus 4. The good news, if you do have a trinomial under here, it's going to be a binomial squared because the whole idea is what pulls out. So at least your factoring is going to be pretty simple. Okay, and then what else do we have? J, radical 25 y squared. So that answer, 5y. And then K, we have the square root of 1/4 t squared. Okay, don't let the fraction scare you. What's the square root of 1? 1. The square root of 4? 2. So 1/2 is the square root of 1/4. The square root of t squared? T. Okie dokie. So for today, you're going to work on page 489, numbers 1 to 27 odd, and 55 to 63 odd. All right, so again, please try these. If you get stuck, look at the answer, see if you can figure it out on your own. If you have questions, we'll go over it during our Zoom time. All right, thanks so much. Talk to you tomorrow.